any questions from any of that. So again, start thinking of project team related ideas, and there's a Discord voice channel now. I guess with that Discord voice channel, I won't be talking to it, so there will be a slight delay. I'll be listening and I'll respond on the stream, but I didn't want my voice to be routed to two different locations. You'd probably get some weird feedback and things like that. But hopefully it works out okay. That's all the excitement for me. So if you're all good with that, let's talk about the exciting world of process models. I need caffeine for this one, and you all do too. Fair warning. All right, where's my little... There it is. Okay. So, process models. We're still in this aspect ratio, so I'm going to use these slides again, because again, it's out of an old textbook, but these are still very relevant, which is interesting to me. To me, the person who likes to make his own slides, I'm using somebody else's for this. But I want to give you kind of a history of where we're at right now and what we're going to be talking about. So we've talked about the phases of software more or less, right? We've talked about how we actually define software, how we implement it, what we're going to have to be doing after that at a high level, because we're going to be getting into it throughout the semester, obviously, but you know that these steps exist at this point. We've talked about quality and stakeholders and trying to figure out how to solve problems. We haven't really talked about implementation too much again, right? Because we're going to assume that's a given that we can't do this stuff. All these umbrellas, activities surrounding software development is what this class is all about, which is why I said strap in with some coffee, because it's not the most exciting thing in the world, but I'll do my best to at least make it interesting to you. But all of these things in here that we have to do, we need a process to handle, right? So Google, if you could get rid of your little bar there so that you stop hiding my screen, I'd appreciate it. Please go away. Otherwise, I'm going to have to kill you manually. Fade out. There we go. And it's back. Okay. We're going to do this the old-fashioned way. Sorry, this is bugging me. Where did you go now? Nav bar floating. There you are. Deleted. Haha. Web development teaches you that. Okay, so software processes. This is going to be a rigorously defined series of steps that you follow during any kind of software engineering project, whether it is the simplest Excel macro that you're setting up. And spoiler alert for those of you going into industry, everything's going to be Excel, everything is going to be PowerPoint and Word, and you're going to be amazed at what people can do with Excel scripts behind the scenes, the VBA macros. You're going to want a process for that type of thing because this is going to be a big part of it. And process, that's when you're developing the software, not like writing reports or anything like that. But developing an app, developing a Windows application, developing an Android application for Android Auto, which is going to be the big thing now that Ford and Google have a relationship. I don't know if any of you saw that article came out yesterday, but Ford is dumping Microsoft and is going with Google, and Android Auto is going to be on all future Ford cars. So get into the Android space because there's going to be some automotive work in that domain, I would guess. Anyway, a little bit of an aside there. This process is just going to be a series of steps. And we're defining it at a very high level here because we don't care what the process is. And that's kind of the secret here. We care that you follow it. We care that you follow it very precisely. But as long as you have a process, that's going to be good enough for us. Right? Because that's going to take you... Where'd we go here? Nope, up. It's going to take you through all these phases of software development. It's going to give you checkpoints along the way saying, yes, you did a good job with your requirements, move on. Or, hey, you need to talk to the customer and get some more information about this particular use case or this particular user story or whatever it is. Basically, the process is going to help you do all of these steps of software development correctly. Because if we don't have a process, then there's a very good chance we miss something and then you end up with some kind of catastrophic issue. whether it's a simple recall, which costs you millions upon millions of dollars, or a problem, which I had you all reflect upon. All right, so process. It's going to be everything we're talking about for probably the next couple classes. But with that, I'd like you all to think about how you've developed software so far. So I've got this set as an open text thing, so you can just put like a sentence or something in there like that. But I want you to think of every time you've been asked to develop some kind of software, whether it's for a term project. Yeah, a term project might be a better example since it's a bigger thing to dig into. But I'm curious what your typical process is. So don't just think about professor gives me the question and then I write code, right? What are you doing mentally to figure that out? That's kind of what we're trying to get at here. And I can tell you mine while you're thinking about this too, if you want, or typing it in. Drawing. So when you say drawing, do you mean like you draw out what you need to do? So you kind of get a little, what's the term? Do like a UI prototype and you draw it out? Planning out steps to take. Good. That's what you should be doing, honestly. Yes, okay, good. Understand how many different classes I need and what every one of them contain. First, think how the parts interact and what functions each part's responsible for. Yeah, there you go. Basically, you're thinking about how to develop it before you start writing code, or maybe you prototype things and then you build onto that, right? Create the framework to get familiar and then work on the harder parts and sections. Okay, writing requirements. Good job. Establish end goals. Find legacy. Specialize. Test, debug, hate myself, fix everything, ship product. Love it. I don't have to impart any of my cynicism into you, I see. That's good. But yeah, so what I'm kind of getting here is that you're all actually thinking about how to develop software, right? If I gave you a project that was like, write a recursive function to calculate a remainder, that's your standard intro to programming assignment, right? Calculate change. You would all look at that and say, and then you might just start writing it, or you might start planning out, do we need a recursive function? Can we do this with the for loop? What do I need a class or two classes? So you're all getting this, which is good. The point is that everybody's process may be a little bit different, right? So maybe some of you like to start writing code first to see if it makes sense and then iterate it, right? So that's more like a prototyping approach. Some of you like to actually sit down and think about it, research and design or write requirements, establish end goals. You're kind of laying down the groundwork mentally, either in writing or you're drawing it out, but you're having a goal that you're envisioning and then you're writing software to that. Some of you might just pull down packages, try to leverage pre-existing APIs, and then see. Yeah. So kind of what we're getting at here with this and what is good to see is that, you're all thinking about software development differently. Some of you have very common, things in common, I suppose. But everybody's going to have a different approach, which to me is a nifty thing. And these all are reflected in industry too, I should mention as well, right? There are approaches for software processes that are very similar to all of these. All right, so what is a process for us in class? In software engineering. This is going to be something that tells you exactly what to do at each step of your software design lifecycle. And this term, software design lifecycle, is something that you're going to become intimately familiar with, but it's this little, kind of circular process cycle here. Design, implement, test, maintain, continue on along the way, and it's going to be different for every project. But what are we doing? What resources are we going to need? What constraints are going to be on those resources? Sorry for the giant wall of text here, but you may have resources that are in a schedule. Resources could be people, right? You only have, Your quality group for 2 weeks this month, make the best use of them. How do you schedule their time? Or, you have access to a cloud resource for prototyping and development, but we've only paid for 3 months of that. That has to be slotted in over here. Basically, it's going to tell us what we have to be doing. Do we get intermediate results? These are going to be like release candidates or alpha builds, basically things along the way that help us see if we're going in the right direction, and then we can communicate that to the customer. Final products go with that, right? And it's going to come with a whole list of basically like audit logs, which are going to be, yes, all of our test cases passed, yes, our user acceptance test passed, everybody's happy with the software, we've delivered it. Each process that we have is going to have a bunch of sub-processes too, and this is going to sound really, really dry and boring, and I apologize, but basically what we're trying to do with all of these bullets here is try to get you to follow a rigorous schedule for your product. And it's going to become very, very clear here that some processes are better at different types of product or different types of projects. And we'll be getting to that as well here. And I lost my I lost my notes because I killed there we go. Just trying to figure out where I am in the slides here. Okay. So we have our process, we have principles, we have products. This is what we're building here, right? With a process, you also get this kind of nice benefit of consistency. And consistency is something that is very important for you as a developer because you want each project that you work on to be consistently of a high quality, right? If we're going to use this process today, and then we're going to switch to another one for the next project, and then we're going to switch again, we're going to switch again, and you start hopping from process to process to process, you might not get good at anything. You might get an okay product, which people are somewhat happy with, and then that kind of reflects on your user trust. They don't think you're a very consistent developer, and maybe we give our business to somebody else in your domain. Right, all of these things kind of have a bubbling effect throughout, which is kind of fun to look at from an outsider's perspective in a way. It also gives you structure. Again, you as software developers, software engineers, are probably going to thrive on a structure because if we have a set of defined tasks and goals, then you know exactly what you have to do day to day, right? You know that today we're doing documentation, tomorrow we're doing implementation, the day after maybe you have a code review that you're building towards. You have a set of goals to hit. And if you have none of that, if you have like a free form, I have no idea what to do today, you're going to start feeling lost and maybe not happy with your job. And I realize the um, paradox of me giving you an open-ended term project probably doesn't help, so I'm going to help you structure that along the way. Don't worry. All right, one other thing here too. Capture our experiences and pass them along. At some point during every project, you're going to have basically like a navel gazing phase or kind of look at what you've done and see what we could have done better, right? We get to project release, get it to the customer. Now let's have a little bit of a look back to see how things went this year on this project. Well, in the requirements phase, we kind of sloughed off and didn't do a great job because we were busy working on this other project. Or we didn't do enough testing because we didn't have time. Or we didn't have enough resources because we scheduled them poorly. Basically, processes are going to give us also the capability to see where things went wrong or where things went right, carry that over to the next project. So keep in mind, we're imposing structure and consistency here. All right. Let's see here. All right, so the last reason, last thing for why we're using a process, and we're actually going to be getting into what they are pretty soon. Again, this is everything I've been saying so far, so I'm not going to spend a lot of time here. But it's giving you structure. It's putting everybody in your team on the same page, and it's going to reduce uncertainty and inconsistencies, right? So hopefully you get a good product at the end of the day. And keep in mind, the reason why we're talking about all of this kind of stuff is that right now you're working on teams of 2 to 4 to 5, right? You've got tiny project teams. most term projects, you're probably going to be by yourself or maybe with one or two other people, right? And here we're making them a little bit bigger to give you the project team feeling. But when you go into industry, your project teams are going to be tens to hundreds of people, right? And these are going to be all your stakeholders in the project, which you talked about last time. If we don't have a consistent structure for everybody to follow, we're not going to really be able to orchestrate a good project because people are going to be left out and not know what they have to do. Keep in mind, too, that a process is going to help you with communication between team members, right? If we are at X phase of the process, we know that the requirements team and the implementation team have to start talking, right? They have to pass on their knowledge to the next group or they have to work together to refine things. If we don't have that pipeline between our teams, then we're going to have a really hard time delivering something at the end of the day. So just keep that in mind. All right, good so far. That's my intro to what processes are and why you should use them. Now we're going to actually talk about what they are. So we're going to see very, very common activities for all of our processes that we're introducing here. And I've mentioned the software process or software development lifecycle, software lifecycle, software process lifecycle. There's multiple worms, but typically the term software and lifecycle are in it. It's just a cyclical process, more or less. Some of them are linear, but we're going to be doing requirements. We're going to be doing system design. We'll be doing implementation and program level design. We'll be testing. We'll be delivering our system to the customer. And then we'll be performing maintenance at the end. Right, so these tasks are going to be common in every single process we talk about. They may be abstracted a little bit, right? They might be called something different, but they're all going to be there. They're just going to be in different places, or there's going to be different team members responsible for them, but they're all going to be there. Again, from the simplest Excel macro that's going to be released for other people to use to a massively complex, you know, Internet of Things application, for lack of a better example. This is all should be there. Maintenance is in its own little category because it's kind of at the tail end where you're supporting your software. Cyberpunk. It all comes back to Cyberpunk. Basically, don't release software without having a maintenance plan. That's kind of the one of the key takeaways here because you don't want bugs to creep in because people are using them in ways you didn't expect, and then your product kind of looks like crap because you don't fix it. Maintenance is going to be that after delivery phase, and it will be there. Okay, so that is the concept of the model. Now, we're going to actually talk about a handful of them. Some of them are a little antiquated at this point, but it's good to understand what they are. Some of them are more current. Depends on your preference, but more or less, I'm going to hazard a guess that the majority of you will be using some form of Agile when you go into the working world, because that's the new and hot and interesting thing right now. It doesn't always work. It doesn't always save the day. And I am not necessarily the Agile person. I came from a more rigorous environment when I was in industry, but I can see the benefits of it, right? But I can also see the benefits of all these other ones. So let's start talking about them now. Okay. So we've got, these are listed out in order here, from very formal, rigorous, impossible to change process to very, very free form and almost spiritual and cult-like at times. So that's what we're going to be talking about here. Quick question for all of you. Have any of you ever used any of these processes before? Whether it's for like an internship or maybe you're working right now. Or maybe you got super excited about software engineering and started researching it. Not I. Okay, no, that's good. Hey, if you haven't seen it, it's new to you. So I will say this. I remember when I was an undergrad, I was probably a junior, and regardless of all the white hair that you see, it wasn't all that long ago for me. That's what having kids will do to you and the stress of a PhD. But one of my job interview questions was, are you familiar with Waterfall? Are you familiar with Agile? Can you work in an environment that where we are doing this? And I said, yes, of course I know what that is, even though I'd never heard of it. And the interview ended there for some reason. But knowing what these models are and how they kind of apply, it may crop up in a job interview. I don't know if it's still a common topic, but yeah, it's good to know what these are. Okay, so waterfall. This is the old one, right? This was the first process model that came out. It is still used in some areas. So the thing with waterfall, and if you talk to somebody who's currently working and you say, I know waterfall, they're going to cringe. You will actually see a physical ugh reaction because it's slightly antiquated at this point, but some places still use it, so it's good to be familiar with it. Now, this is one of the first ones proposed. This is a great process model when there are no changes to requirements. Went to a virtual information session at GM and they said they use Agile. Yeah. So we're going to actually talk about what Agile is, but basically, if a job is telling you the process they use, that's kind of setting you up for what you're going to be having to do on a daily basis. If they're using Agile, then you can expect to have things like daily stand-up meetings. You might have a Kanban board or a Scrum meeting or something like that. You're gonna have very free-form responsibilities. Today you work on the GUI, tomorrow you work on embedded system communication. It's a lot more free-form. But like knowing what these things are, if they tell you this is the model we use, you know what you're getting into with the job. So that's kind of a nice little bit of information to keep in your back pocket. Okay, waterfall. Keep this part in mind because this is the important part. And when I say stuff like that, it's probably going to be on, I don't know, midterm or something like that at some point. Um, Waterfall is great when there are very, very few changes to your requirements. Basically, you get your requirements and they're set in stone. And there's a reason for that. Let me pop all the rest of these in. Waterfall is very easy to explain. There is not a lot of wiggle room. It is a very rigid process. Basically, you're going to have a series of phases, and I'll pop this up here now, where each box, so each of these are basically sub-processes, and as we go through these, the thing to keep in mind too is to look at the arrows between boxes or bubbles, because that tells you how you get to that phase. These are all different phases of our software development lifecycle. Right, so we're going to start with requirements analysis. Okay, then we're going to go to system design. We're going to come up with our architectures, right? And then we're going to go to program design. Let's do our class diagrams. Let's spec out what the program's actually going to look like. Then we'll implement it. Then we'll do our unit testing, our integration testing. Again, testing small pieces, testing modules put together. Get to our system testing. Test the system as a whole in an environment in which you would expect it to operate. Right? So if you're doing autonomous vehicle driving, you're taking that thing out on the road and testing it in real traffic. Then you're happy with that, move on to acceptance testing. That's when you give it to the customer and they test it out. They may have their own test specifications and their own acceptance criteria for, yes, we're happy with this product. We will now take it, you're done. And then after that, you move on to operations and maintenance, so supporting problems that are discovered. So this is a very linear process flow. What is the problem that you see here? Hopefully it should be blatantly obvious. But if it's not, let me give you a hint. When you see a process model like this, you are expected to follow this to the letter, right? If you violate any of these steps, you get into auditing trouble. And the reason why I say that is that depending on your work environment, you might be responsible to auditing authorities like ISO, there's TS. Basically, these are third-party entities that come and check to make sure that you're doing what you say you're doing. And if you're violating that, that is a huge risk to the consumers out there. especially if you're doing stuff like, hey, we're building autonomous cars, but oh, we're sloughing off on testing, while these auditing agencies come in and say, hey, do a better job. Okay, when the client says they want a different product, you can't go back and fix initial mistakes. Problems may occur after you pass. All correct. Absolutely. So what you're getting at here is there is no way to go back short of restarting the whole process, right? Yeah, so those answers are all perfect. Let's say that we do our requirements analysis phase. This is, again, where you talk to the customer, figure out what they want. Internally, you deliberate what the product should look like, and you have these can be 100-page documents of sentences specifying everything the system does. And there's going to be a lot more to it than just writing plain English. You're going to have to link everything together. There's a lot of things going on that you'll get to. Okay, so you get through there, you design your architecture and do high-level diagrams, do some low-level diagrams. Then we start coding, and we realize, oh crap, we screwed up requirements 5 through 20. You can't just fix them and move on. You have to go through this whole thing again because everything depends on everything else. It's like a cascading effect, which is why they call it waterfall. But let's say these requirements impact a bunch of things at the architecture level. That all now has to be reevaluated. Same with the program design. It all kind of builds off of each other. And if you screw up, you have to restart this whole process. And each of these boxes could be weeks to months of effort that you now have to redo. And it sounds awful when I say this right now, right? And you're probably listening or half listening to me talking about the most exciting process model in the world. Um, okay, yeah, that's fine. But there's just so much effort involved here. But the thing to keep in mind, though, is that if this requirements phase is set in stone and there are going to be no changes, and you can guarantee that there will be no changes, this process works fine. All right, question about one of my prior statements. When an auditor comes in, they evaluate you on whatever process model you say you're doing. Do they have previous knowledge? Yes. So let me give you an example from my automotive days. We had a auditor come in, and I guess maybe I should clarify this. They may audit you for different things. Like you have people coming in to audit your software process. You may have people coming in to audit your data or to make sure you're not doing anything funny behind the scenes, because companies are not always the most nice entities, right? But if they're coming in to evaluate your process, you will tell them, yes, we are doing Waterfall. Here is our documentation of all of our checkpoints. Here are the steps we follow to get, let's take requirements analysis, for instance. We give them a timeline of all of our efforts. We show them all of the checkpoints we have passed. And if we've done it correctly, they're happy. Yeah. That's kind of the thing, is that designing a product is going to be different for every project, right? So my waterfall might vary slightly from the standard waterfall. So you have to provide them, these auditors with, this is our process we follow, and they just care that you're doing that, right? There's not like a standard, okay, you have to do this, 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 and this, otherwise we're going to be angry with you. They just care that you're doing what you say you're doing. There's probably some wiggle room with if you do it poorly or not, but yeah. And just to give you an idea of what that means, so let's say that we're being audited, okay? One of these government or non-government bodies comes in and checks your process. Let's say you fail your audit, right? You know, we just checked off one of our areas because we didn't want to go back and redo some effort, which happens in industry, unfortunately, because there's no time or money for it. If you fail an audit check, you might get a certification pulled back. And let's say that certification is tied to what you are rated as a company. Well, that's going to have impacts on the people that are, or the companies that are buying your product. So let's say I'm working for an automotive supplier, to take personal experience here. right? We are building parts for cars. So like we're building components for the big three. So GM, Ford, Chrysler. Sorry, is it Fiat Chrysler now, or it's not Daimler anymore? Or maybe European manufacturers or Asian manufacturers or whatever. We have a particular safety rating where we are licensed to build cameras and radars and lidars and things that are used for the safety of the car. Well, if we fail our audit check, that safety rating goes away, meaning the big three no longer buy millions of our components for their cars, meaning our company has problems because we skipped a step. Again, these all have like bubbling up effects, which are crazy that you can impact a big company as a whole just by failing an audit. And let's say you screw up. I mean, I don't want to go off on too much of an aside here, but you do have a chance to fix things too. Like maybe it's an oversight, it's not intentional. You can fix that kind of stuff. But I'm talking about this from a perspective of a big company. If you're a small company, you're a startup, you can't afford that kind of bad publicity. Your company goes under very, very quickly if you lose your certifications and your um, user trust. But to processes, this is fine when things don't change. When things change is the problem. And as you are all aware at this point in your burgeoning developer careers, you know that things will change very, very quickly. So, kind of an antiquated view where we make the assumption that the customer's requirements are never going to change, right? So, yeah, the issue here is that there's really no iteration possibilities, right? With our process models, we care about the arrows that we're following so that we can go back and change things if we need to, right? If you're following Waterfall and everybody on your team is on board with this, we need a way to go back. And if it's not defined in your process model, then it doesn't exist, right? If you tell an auditor, we're doing Waterfall, but hey, at coding, we skipped back to system design and restarted there, that's going to be a problem because you're not following the correct model. So yeah, most of our software projects that we have are going to have some way to go back in time without resetting the entire project to square one, right? So here's a figure. This is not a real process model, but you just basically want the capability to move around in your life cycle. So waterfall is okay. However, it's basically it's an older view of software development is what it is. It comes from a time when customers gave you requirements and those never changed, right? That was software development in the 80s and 90s even. No changes. Now customers might want a different product, like one of you said. Maybe we discover flaws and then, we can start iterating here. So issues that we have, requirements are frozen. It also kind of looks at software development as a manufacturing process, right? Again, this is another older view of software. It is not a artistic process. It is not a creative process. It is a manufacturing process where software comes down an assembly line, gets built up, and then we ship a product. You all know that software is not like that, hopefully at this point. But when we were looking at software that way, this made sense. But we don't look at it like that anymore. Another thing too, which is one of the other drawbacks, the clients and the customers have a very, very long wait before they get the final product, which if you look at the model, hop back here, makes sense. They don't see anything until acceptance testing, right? There's no, hey, here's our prototype, here's our alpha and beta builds. There's just the final output. So your user base isn't going to see something until it's done. Back in the olden days being 30, 40 years ago, that was fine. That's what was accepted. Today, that doesn't work. Okay, so moving along ancient history, let's add prototyping capabilities to Waterfall because we still like Waterfall, right? It's still a valid process model, but how do we get our customers and our clients to understand what we're working on? I guess, sorry, let's look at this here. So looking at the standard waterfall, again, they don't see it till acceptance testing. what happens if you design your product and everybody inside your team loves it, your company loves it, and your customer hates it, right? They see it, the user interface is crap, there's no, it's very slow to use, the performance is awful, it's got security holes, whatever the problems are. Customer hates it, go back to square one. Again, clients are the worst things to happen to our software products, right? Because then they start having their opinions on things. Let's start throwing in prototyping. So along the way, we can make little builds of our software and give it to the users, give it to our development team, give it to our quality team, show them where we are going. Now, are these prototypes fleshed out, ready to go builds? No, absolutely not, right? They're not ready for production, but they give you an idea of what we're doing. They help validate all of these artifacts that we're developing, right? All of our requirements and models, our code and our tests. It's helping us along the way with that. And it's also giving the customer an idea of what you're building. Do they like the interface? Do they like what it's doing? Is it doing the correct things from their perspective? So building prototypes can be very, very helpful. You know, you all see this type of thing when you get like alpha builds of apps or games or things like that, where it's not ready for everybody. The developers are actively soliciting your feedback to see what everybody likes and doesn't like. The games industry has kind of run with that, turned it into the early access model, and then there's a lot of burnout. And, you know, it's not always a great thing, but when used appropriately, this can be a very powerful tool. So how does this fit in with Waterfall? Because we're saying let's tack prototyping onto Waterfall. Well, at requirements, system design, program design, we can start building little prototypes, right? Little throwaway pieces of software. Now, does this add on time to your process? Yes, of course, because you're taking the time to build a software release, but it can save you a lot of time by not having to go straight back, right? It gives you that capability to sidestep this massive pain of restarting the whole process. I'm sure there's a lot less time involved in building a prototype than it is to get to acceptance testing and redo a year's worth of effort. And with that too comes these little dotted lines going back to previous levels. You know, let's say that we go through all of our life cycle processes here and then we get to system testing, for instance. You know, these lines can be kind of malleable because we can now go back. It doesn't just have to be at system testing. But we discover that we don't like what we're doing or there's problems. Well, now we can say go back to system design or go back to program design because the issues that we're seeing are not at the requirements level, perhaps. So you might be looking at this and saying, okay, it's the same thing with extra lines. And that's exactly what it is. But those extra lines are the process that we're following. Okay, so that is Waterfall. We threw on a prototype, so that's Waterfall with prototype. We're going to talk about one more here and then we'll call it a day. There is the V model. Now, the V model is the one that I grew up with in industry. Okay, this is what we used in my old job. This is basically Waterfall with style, I suppose. So when I say it came from a very rigorously defined software process background, it's because this is the one that we followed. And honestly, it worked fine for us because our product that we were building, we had pretty set requirements, but when the customer wanted something different, we could go back and make updates. It's still a very rigorously defined model, though. So, what is the V model? Let me pop over to a picture here, which will maybe help you visualize a bit. We still see all of the same steps, right? Requirements, system design, program design, coding, unit testing, system testing, acceptance, operations. These are all there. They're just laid out differently with different arrows in between them. So it's called the V model, basically because you have, you know, on the left side, basically you have your requirements and design steps. On the right side, you have your testing and maintenance steps. So it's kind of you're sliding down towards coding and then you're sliding up towards released. You can visualize it however you want. But the key is that you can go back along this V Generally, I don't know, it's typically pictured as things on the same level you can go back to. You're gonna have something kind of arrow-like like this, but what you're seeing in these three different visualizations of V is that at every step of the way, we have the flexibility to go back without going all the way back to the beginning, is basically what we're doing here. So effectively, we're going to be doing a lot of testing along the way to verify our requirements, verify our designs, verify our program models, verify our code, and then if we have issues, we can go back, right? So we have trying to figure out which is going to be the best one to talk about here because these are all looking very, very similar, right? This is probably a better one. So one other thing to talk about with these models too is that I'm showing you this in terms of boxes and arrows, right? And I'm kind of alluding to the fact that there is some massive effort behind each of these boxes. One of the key things with these process models is how you get into a subprocess and how you get out of one. So following the V model is kind of a nice way of doing that here. Let's say you start out with your project definition, right? GM wants us to build a radar for them, to use an automotive example. Okay, so we get the contract. We're going to start building a product. Requirements modeling. We need to have interactions with GM's engineers, with their design teams, figure out what they want. We're going to have our own internal meetings to figure out what we're going to be doing. And then at the end of this phase, we should have a requirements document, right? So the input's going to be that we have a project and we have customer input and maybe stakeholders and team members. The output is going to be the requirement spec. So if we don't have that spec done, we can't leave this phase, right? It should be entered into one of our configuration management systems or requirements management tools that are out there, which we'll talk about a little bit later on. But everything should be there. We're not getting out of requirements if we haven't developed the requirements. Then we get into architecture design. Input is going to be that requirement spec. Output is going to be a series of, it depends company to company, honestly. You might need UML models for the architecture. Maybe it is going to be something like Simulink models where you have an abstraction of what your software is doing. It kind of depends on what your approach is. Not everybody uses UML in industry. I hate saying that since we're going to be doing UML, but not everybody likes it. It could be just written out architecture statements too. So it could be just plain English. All right, going into that, requirements, going out, we have our architecture. We don't get to move on until everybody is happy with the architecture, right? We have meetings where everybody goes through our various architecture artifacts. And again, this is the high level modeling of the system. Are we happy? Have we passed this gate? Get a big green check mark, we can move on. If we don't get that big green check mark, we're stuck here revising. And the same process is going to flow all the way to building the software and then testing the software. Does our software pass unit tests? No, don't leave unit testing until it passes. We have our separate modules now, right? Let's test them together. Let's build a release candidate, perhaps. Does the integration test pass? Yes or no? Well, you're stuck here, or you go back. Because maybe our integration tests are failing because we have a bad design somewhere. Same with unit testing. If you don't get to leave this step, if it's failing, might be a problem with your code, right? Maybe you specified a function wrong. Maybe you specified an iterator wrong. It just kind of depends. But the key with all of these is just to basically follow the process. Again, this is the VMA, or sorry, this is Waterfall with extra flexibility. That's all this really is. Key with these processes are where the arrows are drawn and how you can go back and forth in the process. So we're going to call it here for today. Anybody have any questions, comments, concerns? Super excited about process models, I'm sure. If you go back to step one from acceptance, do you have to go through them all again? Yep. Depends on your model, though. So with this particular approach, the arrow goes this way, which is kind of interesting. This one's actually kind of not a great one because you're using acceptance testing to test out your requirements, but it just depends on where your arrows are drawn in your process. So yeah, if you screw up acceptance testing, you probably have to go back and restart. Will we be meeting with our groups more and starting to work on our term projects? Yes, so if you came in late Friday, we're going to have a little bit of time in class for you all to talk in your Discord channels towards the end. Um, and I'll give you some time sporadically throughout the semester to work together. And last question, is there a most common model or is it based more on project types? So that's a great question. Let's end with that one. I don't want to hold you all too long because we're at time. There are two approaches to that. Do you pick what is currently sexy in the industry? Everybody loves Agile. We're going to do Agile, even if it doesn't make sense. That's the marketing approach, right? We're using Agile. Woo! It's fun. Or there are the people that actually stop and think about if it makes sense. It so to your question, it should be more based on the project type and on your company culture. Is crunch abused more? You know, that is a great question. I I'm not sure, honestly. Crunch tends to happen when you don't plan adequately. So I would say that's probably in all processes. Crunch is the result of poor planning. That's all it is. Basically, if you don't plan adequately for time and resources, you're going to end up with crunch. And if you're in a crunch cycle, you'd better darn well be sure you're paying your engineers and your project teams overtime because it is a terrible thing to have to deal with. Alrighty, so yeah, we'll pick back up on Friday, so we'll do more process models for 3/4 of the class, and then the rest of the class will be project team time. So I hope you all have a wonderful day. I will see you Friday, and if any lingering questions exist, I'll be in office hours. You too, thank you. Um, yeah, crunch has been an issue in game development for a long time. I couldn't really answer that, but my informed guess for game design and game companies is that it's because it is a poor planning issue, honestly. What happens is that you release previews of these games and then the marketing thing picks up steam, and then there's this expectation that you're delivering way too early, and then you crunch, right? But yeah, other than that, I will see you all Friday. I like making video games, and I have no desire to work in the video game industry because of that. Yeah, no, I agree with you on that point. Absolutely. If you can hold yourself to a quality product, it's this weird thing that keeps coming back, honestly, with games at least. I would rather a game be delayed for months to years if it comes out polished, because all of that goodwill that, say, Cyberpunk and Fallout 76 had is gone because they put out a crap tier product. If they had waited, polished things, and then put it out, there would be so much less damage to your company. Exactly. Don't make your hobby a job. All right, I should probably get off stream, otherwise I can stand here talking all day about this. But yep, see you Friday, everybody. Bye.